Hello everyone, welcome to Sources classes. So in this video again we've come up with a very interesting question for you, question pertaining to quantitative aptitude section, and the question with regards to the concepts of divisibility by 11. Okay, so this sort of questions like unique numbers like 11, 7, 13, 17, this sort of questions are quite frequently asked in multiple examinations as well. So these numbers are pretty unique and they have a certain set of divisibility rules which should be kept into mind while solving this question. So in this video we'll take a look at one such question wherein we'll be dealing with the divisibility of 11. Now this sort of questions are quite prevalent, be it in your GRE exams or GMATs or any other entrance based examination which basically imply a quantitative aptitude section. These sort of questions are quite frequent in the numbers system topic. So we'll take a look into that, we'll try and solve the same and also try and understand the divisibility factor or divisibility law with regards to number 11. Okay, let's focus on the question at hand. Find the remainder when 7777 up to 103 digits is divided by 11. Okay, so we have a number 77777 dot 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 777. So this is 100 and 3 times. Okay, this is mod 11. Okay, so we need to find this. So now before we approach this question in general, let us first try and understand the rule pertaining to the divisibility of 11. Okay, suppose I have a number, say A, B, C, D, E, F, G, H. Okay, suppose I have this number. Now for this number to be divisible by 11, okay, to be divisible by 11, so odd places minus even places has to be either 0 or factor of 11 or 11k. Odd places, that is A, C, E and G, even, that is B, D, F and H. So basically A plus C plus E plus G, this is summation, no? This side summation, minus B plus D plus F plus H. This has to be 11k or 0. So this is the entire concept pertaining to divisibility by 11. Okay, now we'll use this concept in this question as well. Here you can see there are 103 times 103 sevens. Okay, now notice one thing, 7 7 7 7 7 7. Okay, dot dot dot. Now see, this plus this gets cancelled out with this and this. Okay, because plus minus goes. Again this plus another one, say this, will get cancelled out with this 2. This trend continues till there are, see, even number pairs are getting cancelled out. Okay, till even numbers, all the numbers are getting cancelled out. So see, even, because 2 gets cancelled out each and every time. So till 102nd 2 digits, till, see here, everything will get cancelled out. Okay, plus minus everything will cancel out, and the 103rd, that is 103rd digit, that is the 103rd digit sum, will only be left out. Okay, mod 11. So this entire term basically would give us 0, because all the alternate terms get cancelled out. This cancelled out, this cancels out, this and this, subsequently everything gets cancelled out. Only one term is left, that is 7. So whenever we will divide this number, our remainder will simply be the remaining 7. That is 7 will be our answer. So I hope this question is clear to you. The concepts and with regards to the approach and everything is clear to you. This is a very interesting question. So not directly interlinked with the concept as well, but we have a direct application of the concepts is not that, but we do have to derive with the solution in this regards as well. So if you have any doubt, just go through the entire discussion, go through the explanation I've given. That should give you plenty of insights in this regards. Now having said that, if you're looking for detailed solution of the entire paper, please feel free to connect with us. We'll be more than happy to help you out in all this regards. Okay. Having said that, if you like the video, make sure you like, share, subscribe to the channel so that we can keep coming up with relevant content such as this further down the line. With all that said and done, I'll be signing out. So thank you so much.